Hi everyone and welcome to this webinar. In this webinar we'll cover a few ways to use already existing portfolio payout functions on the Alphien platform. For those that are not very familiar with what portfolio payouts are, I suggest that you read the documentation that I will show you in a minute. And basically it's about generating weights in order to construct your portfolio. Let's get started. First of all, I have a few forwards for you. Please all mute your mic if it's better for experience of everyone. Also, there is a text panel on the left of your screen that you can fold and unfold. Please type in any questions you can have along as I present, and one member of our team will stop me and relay the questions when appropriate. We also encourage you to replicate what I will show on the screen so that you can have more experience and are more involved into the coding, and that will also help you to see where there are questions to be asked. So with these forwards, let's dig in directly. So I'm just going to start showing this familiar landing page of your Alphien environment. For this tutorial, I'm going to use in priority Alphien Studio, but you can find the support notebook here on the notebooks under Notebooks, Alphien, and Alphien Webinar. So this will be available to you at the moment. It is actually. You can follow from there, or like me, just go directly to your Alphien Studio, and you should, as always, start with choosing QLib if you haven't done it. My environment here is fully loaded, so I don't need to run it myself. So what we can do when the environment is ready is just fork the template for this webinar. It's quite easy. You just need fork template webinar. And this is going to open this support script for the webinar. So you can see the topics that we will cover here during the webinar. It's about portfolio payouts, as I said in the introduction. First of all, we'll see equal weights and static weights portfolios. Very simple portfolios is just to get a sense of what data we are dealing with, and to have a sort of benchmark in your mind about what the backtest period looks like. Then we'll move on to two typical payouts: the mean VaR portfolio and the equal risk contribution portfolio. So this is where we're going to spend most of our time in this webinar. And then, as a bonus for people who want to read a bit more about it, there is a way to combine all these pre-made payouts. I'm not sure we will have time to cover this today, but it is in the script if you want to read and go further. So let's get started. Obviously, as we said, the first step is always to source the QLib so that our environment is pretty ready to use Alphien's functions. Once we have done that, you should see everything loaded in your environment on the right panel. Let's dig directly in the equal weight portfolio. So what is the equal weight portfolio? It's pretty simple. It is a way to keep the weight to each underlying asset equal through time. So I suppose most of you know already the data set, but I'm just going to show it quickly for those that are not familiar enough with it. You can directly call it here. These are the building blocks that we can invest in, and here we see we have three building blocks: TY, US high yield, and banks. So this is pretty much what we have at our disposal to invest during the Alphien, and it goes from 2009 to 2019, well actually 2010, this is the end of 2009. So what we are going to do first is to try and build this equal weight portfolio. So as we see, we have three assets. It means that we are going to give equal weight to each of these three assets. So a third, a third, a third for each of them. As you know, the way to build portfolios on Alphien is to use this function, portfolio. We can see that it requires a list of assets. So I'm just passing in the list of assets, of the three assets that we have here. And then we are going to apply the payout that is called equal weight on the platform. This is already available payout for users to use directly. And then I will cover this line just after the first run. Let's run it without this line first and see what happens. So we are here building the portfolio of equal weight throughout these three assets, and we will then backtest it. As you know, and as it's stated in the rules, we have for this competition some trading costs that are being applied to each of these three underlying assets, and rebalancing penalty that is affecting our strategy each time we do some rebalancing. So it's 2 basis points here per rebalancing. So we have our portfolio that is being generated. Let's just backtest it. And what we can see here, we've left this line 20 out, is just we affect every day the same weight to the three assets. So naturally what's going to happen is that we're going to have pretty horrendous performance here, minus 10% on the period, due to the fact that we are doing, here we go, this is the output of the backtest. Oh no, this is not the output of the backtest, sorry. It was not generated correctly. My panel was too reduced for it to show it. Let me just regenerate it. But here you can see that we have very bad performance, and that's due to the fact that this payout every day we trade the three assets to rebalance them and to maintain them to a state where they are a third, a third, a third. Now that we can see the output, we see that basically it's going straight line down, and that is mainly due to the fact that we're paying a lot in rebalancing. So we have put together for you a function. It's called mean rebal frequency, and that is basically optimizing the number of rebalancing that are needed by this logic, which is to keep an equal weight to the underlying assets in order to avoid this behavior. So basically, when we don't know how a function works, we can always go and check the documentation. Here, the documentation of mean rebal frec is saying that it removes all the dates that are not necessary when we are doing the rebalancing. If we go in the signature of the function, we give it the weight, the returns, and there is a threshold here. The threshold is 5%. The threshold means that we only rebalance when our allocation are drifting away by more than 5% from what our previous weights were on these three assets. So as you know, if you buy a third, a third, a third one day at a certain date, the market then moves and your weight no longer stays one third, one third. So your weights are drifting. When the drift is more than 5%, then we decide to rebalance. This is exactly what this mean rebal frec function is doing. And so we decide to pipe it to our equal weight. So piping is this operation here that says on top of equal weight, apply this minimum rebalancing frequency logic so that we have a more balanced portfolio. So let's just run this and see that it's going to improve dramatically our performance because now we're only rebalancing when we have to rather than forcing the rebalancing every day and costing us a lot of money in terms of rebalancing penalty. For this, I'm just going to run the backtest on the back of that and we will be able to see that the performance, which was from memory -10% before, is coming back to something rather normal of 340% a year. And if we look here, the behavior looks way more stable than it was before. So this first payout, equal weight, is a bit naive, and it's a bit somewhat simple, but it's a good benchmark to have in mind to see what the buy and hold slightly optimized strategy on these three assets would be over the period. So we know that basically you get roughly 3.4% a year over the backtesting period just to do this simple mixing of three assets. Now that we know this and we have the benchmark in mind, we can maybe explore another quite simple portfolio payout, but which is already a bit more flexible in the sense that we can assign the weights we want. And we might think, listen, there are two assets, US high yield and TY, that are bond-based. So this is fixed income. This is the US Treasury bond, even if it's a future. And this is the high yield ETF representing US high yield bonds. So we might decide to allocate a bit more to fixed income than to European banks, which are stocks. So we can explore this and see how the portfolio is impacted. Here we're going to use in these lines what's called static weight. So we are just going to apply a set of weights, and this set of weights, just similarly to what we've done with equal weight, this set of weights is just going to be maintained across the life of the backtest. Again, we were going to chain this payout with a minimum rebalancing frequency function in order to optimize the number of rebalancings. This static weight will basically have the same behavior as equal weight, meaning that by default it will rebalance every day. So we need to use this to maintain the rebalancing frequency optimized. Let's just try that and see that if we put 80% to the bonds and only 20% to equity, what the performance is. So 0.4, so 40% applies to TY, 40% applies to US high yield, 20% applying to banks, and check what sort of backtest it gives us. I'm not sure if you have noticed each time I run, there is this new message when the portfolio gets created here. This is only a warning message. Warnings are not blocking, so you can still see the output of your strategy. And it says that 3 days which had weight actually were not open. So automatically, what this function does for you is to push it to the next trading day. So you don't have to worry about that. It's all handled by our function, our portfolio function. So now that we have the backtest out, we see slightly higher annualized return. We see the behavior here, which is pretty upward sloping, not too bad. You can obviously check the other metrics, 0.74 sharp, with a max return of 13%. So this gives us already quite a view of how the underlying assets are behaving. You know that if you're equal weight, your return was roughly 3.4% a year. But if you move more towards fixed income, you have slightly improved returns here. So it looks like the behavior of the banking underlying is more volatile and is more difficult to manage. So that's giving you a good benchmark to understand maybe what you need to develop a bit more later in order to be able to have a better payout and a better strategy. So these two, so the equal weight and static weight, were somewhat easy or intuitive payouts to put in mind, to put in place. However, you might want to have a slightly more complex. I'm sorry. Can everyone make sure that they have their mic on mute, please? Yeah, thank you. So you might want to get a bit more advanced in the way you construct your portfolio rather than keeping the same weights all the time. So this is what we're going to do. We're going to start looking at typical or standard payouts in portfolio theory. And the first one we're going to look at is the minimum variance portfolio. So the minimum variance portfolio, here we have a link that I have put that I'm going to copy. And we're going to be able to see the documentation about it. I'll come back to that in a minute. But roughly, just as an introduction, I'm just also going to run it, and then we're gonna explain it. But yes, thank you. Yes, Kiang. Hello, everyone. Is trading cost here? Is the same applying stress test function? Exactly, Kiang. All the trading costs here that I have applied are the standard trading costs for the competition. There should be a link on the leaderboard showing you the details. So this is 1 basis point for the future on US Treasury, and the 2 ETFs are slightly more costly, 5 basis points each. So these are trading costs applied to the size of your rebalancing. Independently, there is a rebalancing penalty for this competition, meaning each time you rebalance, be it on 1 asset, 2 assets, 3 assets, each time you rebalance, you are paying a fixed cost rebalancing of 2 basis points. So this here will have an impact on the number of rebalancing you are doing. This here is proportional to the magnitude of your rebalancing. So it's like two different dimensions covering trading costs, if you want. So if you want to be slightly more optimized, you should reduce the number of rebalancing probably to once or twice a month in order to not pay too much in these costs of rebalancing penalty. Then if you want to reduce this part of the cost, then you're better off having small trades than big swings in your allocation. That's pretty much it. Thank you for this question. It's important, as we've seen with portfolio. If we just leave it every day, the performance is catastrophic. So this is a good point to raise.